In this session, we're going to cover an introduction to programming language. The concepts that we're going to cover are what is a programming language, why are there so many, what are the different types of languages, and how do you pick a programming language. So what is a programming language? It's essentially a set of rules that tells the computer what operations to perform. It is, you can think of it as communicating an algorithm to the computer, essentially. So if you think about our language, English is a natural language. It has words, symbols, and grammatical rules. And the same thing goes for a programming language as well. It also has words, symbols, and, believe it or not, rules of grammar. The rules of grammar in a programming language are called the syntax. And each programming language has a different set of syntax rules that you have to follow. So why are there so many different programming languages? Why do some people speak French and not English? Well, programming languages evolved over time, just like languages have, and they have evolved as we have designed and developed better ways to create programming languages. They were first created back in the 1950s, and since then there's literally been thousands of different languages that have been developed. Many times the different languages are designed for different types of programs or for different purposes, and that's something that we'll talk about in a little bit, is how do you pick one. There's three different levels of programming language: high level, low level, and executable machine code. So if you look at the three boxes over on the right, probably none of them look very easy to read, but in general I would guess you would think that the top one probably is a little bit easier to read, and that's considered a high level programming language. Probably most of the programming languages that you've heard of and that people use are in that category of high-level languages. A low-level language is something that is assembly code, essentially, so it's at a lower level. Most programming languages compile into assembly code and then actually into executable machine code. The lowest level is just a bunch of zeros and ones, so those are your bits and bytes. And that's essentially what it all gets compiled down to tell the computer what to do. But from a human standpoint, we typically program at the high level because that's a little bit easier for us and more efficient. There are really two broad groups of programming languages: traditional and object-oriented. So in traditional programming language, there are a sequence of instructions that essentially tell the computer what to do. Part of those traditional programming languages, there are different generations, so there's first, second, and some third generation languages that all belong to those traditional programming languages. But then we also have object-oriented languages, and this is when the instructions are not sequences of code or instructions, but objects are created rather than sequence of instructions. And that enables you to, in the long run, program faster. It also provides for a mechanism to more easily reuse parts of the computer program over and over again. And then typically in object-oriented languages, you have some third, fourth, and even fifth generation languages. So let's talk about some traditional programming languages that you may have heard of. Fortran, developed at IBM back in the 1950s, stands for Formula Translation, and it was really designed for scientific and mathematical applications to be used by scientists and engineers. So way back then when I was getting my undergraduate degree, which was a degree in computer information systems, Fortran was actually one of the required languages that we had to learn just to help us understand kind of the underlying parts of computer programming and how that works. But I don't think in most programs today people learn Fortran. So COBOL was developed in the late 50s. It stands for Common Business Oriented Language. You may or may not have heard of that. There are still companies that use COBOL and have applications written in COBOL, but I would say that now there are probably never any new applications written in COBOL. It's just maintenance of old code. And COBOL was really transformational because it was written for business applications as opposed to Fortran, which we looked at on the previous slide, which was really for scientific and engineering applications. COBOL was written for business applications. And it was, I mean, in its day, probably every company in the world had, were developing applications in COBOL. There's also BASIC, and so that may be one that you've heard of before. BASIC came from, the acronym came from Beginner's All-Purpose Symbolic Instruction Code, and it was developed in the mid-1960s, so you can see we're going a little bit later in time with each of these. And it was developed as a simple language for students to write programs with so they could interact with the terminal. So it was probably a step forward from COBOL in being easier to learn and easier to use. And then another traditional programming language was the C, yes, just the letter C programming language, and it was developed by Bell Laboratories in the early 1970s. So Bell Laboratories was part of the original conglomerate of telephone system companies that I don't know if you remember, this has been many years ago, but the phone company had to divest, and they went into two different companies, AT&T and then the different Bell telephone companies. Here in St. Louis we had Southwestern Bell Telephone. Anyway, in more recent times those two companies have merged back together again, but that's where Bell Laboratories came from. And the purpose of C was to provide control and efficiency of the assembly language while having third generation language features. So it was easier to use, yet it was still very powerful. And it was typically used more for systems type programs, so not as much for business type applications like COBOL was. I think in the first class period when we talked about different operating systems, we talked about the Unix operating system. The Unix operating system is actually written in the C programming language. All right, and so then we have object-oriented programming languages, and probably the most common one is, or one of the most common ones, is C++. So it is similar to the C language, but it has additional features that make it object-oriented. And it was widely used for developing system and application software. Graphical user interfaces can also easily be developed with visual programming tools that were built around the C++ language. Now Java, that's one I'm guessing that most of you have probably heard of before. And it is similar to C++, but many people think that it is much easier to use. C++ has some idiosyncrasies and problematic features that Java does not have. It's very geared toward web development. You'll see here that it says it allows a web page developer to create programs for applications, so web development. With Java you create things called applets that can then be used inside of a browser. So that's the Java programming language. There's also some other types of programming languages. There's scripting languages. So JavaScript and VBScript. So yes, JavaScript and Java are not the same thing. Java is an object-oriented programming language and JavaScript is more of a scripting type language. There's also command-based languages. You'll see some listed here, SH, CSH, and Bash. Many of these are used in the Unix operating system. So with these specifically here, we're getting into the depths of it a little bit. I don't necessarily expect you to memorize all this. The purpose of a lot of this is really just to give you exposure to these terms and to understand what programming languages are out there at a high level. And then, so in addition to scripting languages and command languages, there's also text processing languages, LaTeX and PostScript. Some of you may have had exposure to PostScript before. That is a common language used when programming printers and devices like that. And then another special programming language is HTML. And so here's the first introduction to that we will have in this class, and next week we will go into that in more detail. But HTML stands for Hypertext Markup Language, and it's used on the internet and on the World Wide Web. That's outdating itself there a little bit, I think, but essentially it enables a web page developer to put tags on the page to indicate how the page should be formatted. And so it's a type of language. It's a markup language that enables you to specify what your web page should look like. And we will have more exposure to that in a different week of this class. And then there's another one called XML, Extensible Markup Language. And I see this used a lot now as opposed to CSV files. And so if you've had any exposure to CSV file, CSV stands for comma separated values. And if you've used Excel very much, you may know that Excel can actually export to a CSV file. So it takes that Excel spreadsheet and exports it to a file where all the fields are essentially separated by some value. Comma, the comma character is typically what's used to separate the fields, but it can be other things like the vertical bar is another common thing that's used in those files. But anyway, I've seen XML take the place of CSV files in a lot of circumstances because it provides for a little bit more flexibility and a little bit more intelligence in defining what a file format can potentially look like. All right, so a language is a language is a language. So again, programming languages, you can think of them just like a language like English. We learn English, we learn French, we learn German. In programming languages, you might learn C, you might learn C++, you might learn Java. When it comes to the mechanics, learning a programming language is similar to learning a human language. In both cases, you have to learn the syntax. So in the English language, you have to learn grammar. If you're going to learn C++ or Java programming, you're going to have to learn what the syntax of that language is, what are the words, and what are the different things that you have to, delimiters and things like that that you have to put in the program to make the computer understand what you want it to understand. So in both cases, you have to learn a new vocabulary. There's new words, there's sentence structure, there's meaning that you have to understand. And they both require considerable practice. I've learned several different programming languages in my career, so I would say that I think learning a programming language is easier than learning a different language like English or French, but maybe I just say that because I only speak a single language. I only know English. I don't know any other languages, but they also say that once you've learned one language, that learning, and I'm talking about computer programming language, although I've heard this about languages like English and French as well, but once you've learned one computer language, learning another one is much easier because a lot of it is around the logic and the way that you have to think about a program, and just the reasoning skills and things like that that you have to learn in order to do that. Once you do that, learning the syntax of another language is typically not that hard. So what determines a good language? Historically, it was runtime performance, and that's because computers were very expensive, memory was expensive, hard drives were expensive, so you wanted that language to be, to have the best performance possible because you didn't want to have to go and buy more computer resources. Well, memory and hard disk space and computers themselves are much cheaper than they used to be. So that's not quite as important today. I would say that now the human cost is more important. And by the human cost, that means how hard is it going to be to train someone to use this new language. And so let's say that you're a company and you're trying to decide between, I don't know, C++ and Java. There's several things that you might look at. You might look at how hard or how easy it is to learn one of those two languages. If you're going to have to train your whole staff on a whole new language, you want it to be a language that they can learn quickly, that you can easily design and code, where debugging is easy, where maintenance is easy, and also where it's easy to reuse the code that you've already written in other places. And then there's also fads. There's fads of this language is cool now and another language is not cool. There's that type of thing. But probably from a business standpoint, businesses are going to be looking more at the human cost and also if it's the right language for the task. If you are writing a program, an accounts payable application, like a business type application versus, if you're writing a program to monitor hardware or computers, there's different languages that might be better fit for each of those. So how do you pick? I've covered some of these already. I think the ease of learning, the speed of development, what the performance is, supported platforms. So that's something I didn't touch upon, but some languages are only supported on specific platforms. So if you are going to write a web application, you would probably want to make sure that web application can be used across multiple platforms. So for example, can it be used in all the different browsers? Can it be used on Windows machines? Can it be used on Mac machines? Can it be used on Linux machines? Those type of things. And also portability, if you would need to port it to a different platform, how portable. And then fit for purpose, that's when I was talking about, whether it's a business application versus monitoring some hardware. Those are different those are different uses that might have different languages that are applicable to them. All right, and that wraps up the introduction to programming languages.